This is the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technologies. This podcast series is sponsored by Allied Electronics and Automation, carrying the most automation and control brand names in North America. Now, the questions posed in this podcast series all come from automation technology users like yourself across the process and discrete manufacturing industries. I'm David Greenfield, Director of Content for Automation World, and the question we'll be answering in this episode is, what is IOLink and is it difficult to integrate? Now, I should start by noting that IOLink is not a new product. It was introduced well over a decade ago in Europe, and it's been gaining acceptance outside of Europe ever since. But like most automation technologies of a more recent vintage, acceptance and adoption tend to be very slow moving. So, to get some more detailed insights on IOLink, I'm joined today by Shishir Rege of Balluff, a supplier of industrial sensors, networks, connectors, HMI, and safety products. Now, Balluff is well positioned as a knowledgeable resource on IOLink, as the company's been offering it since 2009. So, Shishir, I've been familiar with IOLink for several years now due to travels to various European automation technology events. But IOLink is not so well known in the US. So, can you explain for us what IOLink is and how it's used?
Hey, David, thank you for having me on this podcast. And you're right. IOLink has gained tremendous momentum in European countries and has been little slow adoption here in the US. To answer your question, I'll start with little historical background. So, prior to the IOLink technology, we have been using signal communication at the device level. For example, proc switches, photo eyes as a standard on-off devices. And then we also use the analog signals from 4 to 20 milliamps or 0 to 10 volts and so on. When we use these signal communication devices, first of all, there is no diagnostics. For most part, we assume that the device is functioning and working until the process comes to a halt and we discover the quality issues. So, secondly, the binary devices that use standard 2 or 3 wire unshielded cable, whereas the analog devices could use 2, 3, 4 wire unshielded cables. And if you have a complex device, such as a laser distance sensor or a pressure transducer, uh, which are analog but also has some digital signals for set points, that requires you to use different types of cables. It could range from 2 wires all the way up to 6 wires. In short, every type of device requires a different set of cables, a different set of configuration tools. And as a machine builder or end user, depending on the devices they would use, they have to stock up the inventory of different cables in order to ensure that their plant keeps running and producing. The IOLink consortium was formed to address this particular challenge or issue with the unified device level communication that is easy to implement and would have more built in diagnostics. Of course, there are other competing technologies that promised about the same things. For example, ASI, or commonly known as AUSI, but that requires a special hardware, special power supply, and it was more of a network at the device level. We needed to address each node. There were limitations on the nodes. The diagnostics was not readily available, and so on were the problems with the ASI. So, IOLink was designed not as a network, but more as a point to point or peer to peer communication technology at the device level. In the simplest form, I would put IOLink more as a USB for industrial automation. It is completely independent of control level network such as Ethernet IP, Profinet, CC-Link, or whatever the version that you have. IOLink is completely transparent to that network or a field bus, and each IOLink device communicates with the IOLink master port for the data. The IOLink master ports are typically reside on a gateway module that communicates and takes that data up to the control level. So that's how the IOLink is architected. Now, the IOLink has three types of data that it communicates. The first, what we call process data, that would be your on off signals or discrete sensors or measurement sensors, measurement values such as distance or pressure, and those kinds of things. Then the second type of data it communicates is parameter data. That would be configuration data to configure the device for set points, events, or alerts, or even engineering units for the measurement. And the third type, which is we call the event data, that this is the data that originates from the sensor and provides important alerts about the system. A good example of that would be a photo eye that indicates if the remitted light intensity has reduced, which probably indicates a cloudy lens or it is out of alignment. So, this type of data is very valuable on the plant floor as the machines now have the capability of telling the operators or maintenance person about the health of devices, and that could help us avoid potential downtimes. Is that helpful?
Yes, thanks, Shishir. That was a really good explanation with some good examples of application as well. So tell me, based on what you were saying, is IOLink widely available in the US now, or is it only available in limited release?
Actually, it is been widely available, and every year there are more and more devices or sensors that are being brought onto IOLink. Now, as you mentioned, you have seen this prominently in European countries. The adoption in US is a little bit slower, but I think we have moved from the introductory phase into that growth phase. And our estimates are it's growing at the pace of about 30% annually. So machine builders are realizing tremendous benefits of using IOLink for quick setup, reduced cost of build, faster commissioning times, and tons of diagnostics. It is also enabling machine builders to integrate more complex devices and things to make their system stand out from the crowd, per se, and also be ready for the next generation of machines, which we all know as the era of industrial Internet of Things or Industry 4.0.
So, from your description of IOLink, it seems pretty obvious that it's got a lot of advantages for OEMs and system integrators. But what about end users? Is IOLink a potential tool for them as well?
Absolutely. There are tremendous advantages for the end users of automation with IOLink technology. Some of these benefits are common, which gets carried out to both machine builders and OEMs to the end users, such as standardization of interfaces, more diagnostics, reduction in network nodes, which are all helpful. But the two critical areas of automation that the end users are always concerned about is the downtime and traceability, or so called visibility in the plant floor. So, IOLink addresses both of these concerns. And so, let's start with the first one. So, IOLink addresses downtime concerns by shortening or eliminating it completely because the IOLink offers nth level of diagnostics with sensors and hubs and tremendously helps debugging quickly. For an example, if there are shorted sensor, a shorted discrete sensor, IOLink points out exact location of that short to help speed up the solution. So people don't have to take out their multimeters and go hunt for the short. Also, with IOLink sensors, the devices are smarter, so they can provide more alerts and diagnostics so that the maintenance of the plant floor can be uh, noted with, hey, there might be upcoming problem, such as the pressure is too high, or I'm not getting enough current, or the remitted light, as I gave an example. That would help the maintenance guy plan the maintenance in a preventative fashion instead of, or we call this a predictable maintenance, instead of waiting for the problem to occur. IOLink based systems also offer this feature called automatic device replacement that comes standards with all the IOLink devices. So when you're replacing a complex device, you can auto configure that device. So that saves a lot of time, saves you on keeping the cheat sheets on how to configure the devices and things of that nature. Additionally, since IOLink can bring in a lot of different technologies. One of the examples would be RFID or barcode readers. So we can integrate those technologies for your work in process or access control to the system, or even when you're changing parts of the machine to run different types of production to ensure that the right parts are in place. We could use those technologies easily without having to add more burden or more complex controllers to manage all that information. So it makes it a lot more easier to integrate different technologies and have a meaningful, I call it a Zen state of manufacturing, where there is close to zero downtime due to these outages. So, yeah, in short, you're getting a lot with the IO-Link adoption.
Now, getting back to the original question from the reader who asked what IOLink is, the second part of their question was, is it difficult to integrate? How would you address this from both an OEM and an end user point of view?
In case of IO-Link, for most part, IO-Link is completely transparent from the control side. The machine builders, end users have zero programming related to the IO-Link setup or maintenance. Now, when I say that, now each of the IO-Link device has parameters and process data that comes up. And this comes up as a stream of data in your PLC or a controller that you're using over your choice of field bus or a network. Putting meaning to that data is where all the meat is. So now, how to integrate that data? There could be a crude way where you pull up a device manual and figure out how the data mapping is and create tables and manipulate that data. There is also the most efficient way would be to use like a function blocks or add-on instructions that automatically map all this data and makes it easier to control or manipulate the information. A lot of times the IOLink master manufacturers or the device manufacturers offer these features readily. That makes it easy to integrate those devices. Additionally, a lot of IOLink master manufacturers offer the integration with IODD files. So IODD is IOLink device description file. So any device that is approved as an IOLink device has to have a companion IODD file. There is actually a website on io-link.com website, which is the consortium website, where you can go to retrieve all these IODD files. And a lot of these IODD files could be directly integrated into your controller or through a web server onto the master. That makes it easy to configure and parameterize your sensors easily. So there are several other ways to configure these devices. Depends on the choice of the manufacturer for PLCs and IO-Link masters.
Now, from what we've discussed today, Shishir, it seems like IOLink is well suited for Industry 4.0, Industrial Internet of Things, or digital transformation initiatives in general. So, would you agree with that assessment, or is there anything lacking with IOLink in that regard?
IO-Link is so far is the technology that came farthest in connecting sensors directly to the cloud. Um, what makes it very attractive, it is a vendor neutral and a control neutral technology. So that offers the connectivity directly up to the cloud. There are several methods you could use to implement for this based on your cybersecurity choices and available technologies. For example, some manufacturers of IO-Link masters or gateways offer JSON, which is a JavaScript object notation interface to publish sensor data directly to the edge gateways. Some might offer OPC UA interface and different type of technologies, or some PLC controllers offer the ability to fetch this data and put it to their historians or other edge gateway modules. So that way, IOLink is a lot more open in terms of getting your systems and factories ready for IIoT or Industry 4.0.
Now, you've mentioned numerous benefits of IOLink in our discussion here today, but for those who are interested in the technology, are there any potential downsides or caveats that they should be aware of?
That is a really good question, David. And while IOLink adds a lot of these benefits, got to understand that IOLink is a point-to-point communication and it is not a network. So it is completely transparent from the control level network. So nobody has to worry about programming IOLink per se. Um, at the same token, it is not a signal transmission, right? It's not a 4 to 20 milliamps or zeros and ones. It is instead a data communication. So the downside of that is there is going to be some time lag from sensor to the controller. And this time lag is the time for IO-Link communication between sensor and the master or gateway module. And then there is a time lag for the network or the field bus that is communicating that data from the master to the controller. So typically it is definitely based on the size of data the sensor communicates. It may take up to 2 to 5 milliseconds for sensors to provide that process data to the master, and then whatever is the time lag for the network setup is. Typically, my suggestion to the customers is if your current network setup is 10 to 15 millisecond for RPIs or the requested packet intervals, then IOLink is best suited for these applications. If the RPI is less than 5 milliseconds, then it depends on how critical the update rate is for your application. And in most cases, we find that 80 or 90% of the data does not have to be updated that fast. And then IOLink can be used for that portion of the control system. So you can reap the benefits of data communication um, while maintaining the the real-time performance of the system.
Well, thank you for joining me for this podcast, Shishir, and thanks to all of our listeners for joining us as well. Please keep watching this space for more installments of Automation World Get Your Questions Answered, and remember to visit our website at www.automationworld.com to stay on top of the latest industrial automation technology insights, trends, and news.